Uh, Hi everyone. Um, Hope you guys are doing great. Uh, we will just wait a few minutes for others to join, and then we will move on. In just a couple of minutes.
Okay. Hello, Owais. Hello, Kira. So let's wait. Thanks.
Um, okay, so I'm going to share my screen. If anyone has any questions before I start with the presentation, please go ahead and ask. You guys can see my screen, right?
Yes.
Okay. Uh, yeah, so in the previous session, we performed image augmentation and uh, cropping on our images. Um, Kiran Kumar actually came up with a very good solution to the cropping issue. Uh, so we will be using his method from now on. But in this notebook, I have used the cropping method that I used in previously. Uh, because I prepared this notebook for the presentation, and I didn't want to make any changes in it. But I will come to that in the end. So the first few blocks of this notebook, this was already covered in the previous lecture. Previous session. So we are just loading images into an array, but there is a small difference this time, as we are preparing this data for training our model. So we are loading the images, and we are also storing their labels. Uh, so for each image, for in this block of code, I am loading the hem images, and then for every him image I'm saving a label called him in an array. This is pretty straightforward, but I also prepared a slide just to visualize it, so you guys, so those who are not familiar with the process can understand it uh, better. So this consider this as an image, this rectangle. So if we store this image in an array, and if this image belongs to an all class, then we also store uh, the label in a separate array. And yeah, we do this for all the images. So if the image belongs to all class, we store a label of all, and if the image belongs to a him class, we store a label of him. Um, yeah, so we are just loading the images and labels into arrays, and then we are cropping them. Again, I will come to the cropping issue at the end of the presentation. But for now, this is just the method that we used during the previous session for cropping, which is we are just cropping 30 pixels from each side of the picture, from top, bottom, left, and right. Um, okay, so we have the images and labels stored in arrays. Um, this is now new. So now uh, we are preparing our data to for for transfer learning. So we will be using the pre-trained VGG16 deep learning model for extracting features from our images, and we will see how we can do that in a moment. So first of all, we have our images in all all images in this array, all in array, and we have our him images in this array, and him in array. So with this, and now np dot concatenate, what I am doing is that, um, let's say I have my all images in one array, and I have my him images in another array. So when I do np dot can concat, I'm just uh, combining these two images, and I'm storing them all together in a single array, and I'm calling that array images. So this line is just concatenating both the arrays. Uh, and this line is doing the same for the labels. So I have my labels for all images in this array, and I have my labels for him images in this array. And by doing the concat, I am just storing all of the labels in a single array. Uh, yeah, and here I am just uh, checking uh, randomly checking labels of an image. So for 6,000, of my 6,000 label is all, and my 9,000 label is him. Um, After that, I'm encoding our label. So those of you who are familiar with machine learning would know that um, machine learning models do not understand string data. So right now my uh, labels are in string format. So when I do label encoder, when I encode my labels, that means that I am converting the labels from strings to numerics. So for every all image, the label will be 0, and for every hem image, the label would be 1. Uh, so this block of code is just doing that. And after the encoding, when I check the labels again, so you will notice that for all the label is 0, and for him the label is 1. Um, and if for again, for those who are familiar with machine learning will know, here I am just trying to split the data into training and testing set. The images and labels into training and testing set. So one set of images and labels we will be using for training our model, and other will be used for evaluating or testing our model. Um, yeah, so in this block of code, that's all that we are doing. And here I am scaling the images. So for most of the deep neural networks, they expect the input images to be scaled. Not the input images, but to be more technical, the 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 pixel values of all the images to be scaled in the range of 0 to 1. So if I before scaling, if we check the max pixel of a random image. So the max pixel value of this image is 103. And after the scaling, the max pixel value is zero point 0.4 for this image. And this will be, for every image, this will be between the range of 0 and 1. So this is like just a common pre-processing step before we feed our images to our deep learning model. And and by deep learning model, I mean VGG16 that we will be using for transfer learning. Um, so this diagram that you are seeing here, um, it is the VG16 architecture, and when we are talking about using a pre-trained model for feature extraction, so what we mean by that is that we will only be using the convolutional layers of a particular deep learning model. So in this case, we are using VG16. So if we have to use this for feature extraction, that means that we will only use the convolutional layer, because the convolutional layers are basically uh, what the convolution layer is basically what helps us to extract features from an image. So if an image passed through a convolutional layer, what we get at the output is the feature, is called the features of that image. So so we will load a complete VG16 model, but we will exclude these dense and output layers because we don't need this. If we do include these dense and output layer, then that means that we are using this VG16 for image classification. But we don't want to use it for image classification. We only want to extract features using this model. So we will remove this dense and output layer, and we will just uh, be using these convolutional layer. Um, so yeah, that's what we are doing here. We are uh, loading the VG16 model, and this include top is equal to false means that we are, this is referred to as top in terms of coding. So we are not including this top, we are only including these convolution there. um, I will show you guys how uh, it converts an image to, or it extracts features from an image. So I have prepared this separate notebook. We will mm, see how it works on a single image. So let me just run this cell. Um, let's wait for it to finish. Yeah, so our VGG model is now loaded, and we will pick a random image. Let me just run this. So this is our image, and we want to extract features for this image. So uh, I will just pass this image to, I will call the dot predict method, and I will pass this image as an input to that method, and whatever I get at the output will be features of that image. So when I do this, now this features variable is storing the features of this image, and we can actually see how these features look visually. Let me just run this. So there are three 512 3 by 3 features for this image, and if we look at it visually, it does not make sense to us visually, but these are the features, and they are different for each image. And yeah, so these should be 512 features, and each 3 by 3, this each 3 by 3 block is counted as one feature. So for each image we will have 512 features. um, yeah, so this is how the features look. We do the same here for all the images. Here I call the predict method on all the images in the train set. And Then by doing this, this x feature or extend feeds without reshape, what I am trying to do is, let's say this is an image. So uh, for in reality, these should be 512 features, but I'm only considering two blocks. These should be 512 blocks of 3 by 3, but I am only considering two. So let's say this is my single image. So when I uh, do the dot reshape, which I showed you here, when I do this x trend feeds dot reshape, what it does is that it will uh, pick this top row of this 3 by 3 block, and then it will pick the next the next row of this 3 by 3 block, and it will um, attach it to the first row. So sorry, sorry for my bad English. Um, but I hope you guys understand what I mean by this. So when I do dot reshape, it just takes each row of this block, and it attach one it attaches them in as a single row. So for this one image, I will have uh, the features by doing this reshape. The features will be then converted to this shape. Uh, so this is for one image, and then we will do this for all the images. So this is what this line of code is doing. And why we want to do this? Because we want to store these features in a pandas data frame, and when they are stored in this 3 by 3 format, we cannot store them in a pandas data frame. But if we convert them into a single dimensional single row format, then let's say this is for one image, this is for another, this is for third, then we can just go ahead and store them in a pandas data frame. So when we convert it into a pandas data frame, then each row represents this single image, and these columns, each column represents single feature of each image. Um, and that's what we are doing here. So we just extract the features and we reshape it into a single row. And similarly, we do the same for the testing set, and then we just store them in a pandas data frame. Uh, yeah, and then I have stored these pandas data frame to or on my disk as a pickle file. So I will be sharing these pickle files with you guys to use them for classification tasks. Um, yeah, so before moving on to discussion, um, so I save these into pickle file. So I have one train data file and one test data file. And if you remember, I told you that I have used the 30 by 30 cropping method for this notebook. So I did this entire process again, and in a separate notebook, and for that I used the cropping method by the cropping method that was shared by Kiran Kumar in the channel, and I got two separate training and testing data files from that notebook, and I have stored them with me right here. So right now I have um, two files, sorry, training and testing data for 30 by 30 crop, and then another training and testing data set for the cropping method that Kiran Kumar has used. So I have two separate sets of training and testing data, and I will share them with you guys, and you guys can perform classification on it. And within the next couple of days, share your results with me, and we will see what we are going to do after that. Um, So yeah, that was all from my side. And if anyone has any questions or want to share anything, please go ahead. Yes, Wallace.
So, Owais, thanks for your presentation and for your work. Uh,
Uh,
it was good for me since the first time I using transfer learning for image classification. So uh, I could understand better some details that I didn't understand up to now. So
so
thanks for your time.
you're welcome. I'm glad that you found it helpful. Um, so I need at least three uh, teams or three guys that can to whom I can give these train and test data and they can perform classification on it. So is there anyone who want to like perform classification on the data frames that I have extracted from the images?
So, Wes, I did something similar from my study this week, as I told you, and I would like to test both ways. So I would like to test the structure I developed based on some tutorials, and also compare with the data frame that you provide.
Yeah, so I was thinking that I will share the training and testing data with you guys, and you guys should perform different type of classification algorithms on it and see what kind of results uh, do you guys come up with. Yes, Kiran? Uh,
Hello, everyone, and hi, Owais.
hi.
Uh, it was a nice. Am I audible? Hello.
Yes, yes, go ahead.
Yeah, thank you. Uh, no, it was a great presentation. Thank you, Owais. Uh, got some heads up regarding how you are proceeding or how is your code. Means mine is a little different. Uh, and the idea of creating two different folders, the cropping code, the automated cropping code which has been created, it's for the folders mainly. So you just give the path of the folder which you want to crop the images. So based on the given path, the images get cropped.
Yes,
So yeah, that's the main idea. Everybody can utilize it. I usually work on Google Colab. Uh,
yeah,
I'm yet to switch the data into my local computer.
yeah,
Uh, I just wanted to give the information regarding. You can just give the folder path, and everybody can train and test their data on it. If somebody wants to add the data, like the Kaggle data, uh, I wanted to include the Kaggle data set into the our current data set also. The problem was the background was not black there, or it was not a dark background. It's a completely different background. Let me try a different algorithm on it and try to crop those images also if possible.
yeah.
I'll
So,
be, yeah,
okay, so you were talking about a different data set on Kaggle.
yeah, Kaggle all and hem data sets, all and normal data sets. There were around some 800 images from Kaggle, I suppose. Similar hematology data sets where we have a single cell classifying them as all or normal.
Okay, okay.
I think I shared those data also last time, and it's in my Google Drive also, which I where the link was copied onto the Slack.
Yeah. So you want to work on that data set now?
No, more the data set means in terms of cropping. Uh, if we are able to crop the data sets and include into ours also, that would be a great idea.
Um, yeah, we can try that, but I am not sure if we combine images from other data sets into our data set if that is going to have like a positive impact on the performance or the negative. So I'm not sure about it, but yeah, you can try that.
Yeah, means when if you crop it, I think the background information will be illuminated there. So it should work on our data set also. That's my idea actually.
Yeah, so
When
we
you crop it, without cropping, if you include it, when will be a problem. But if you crop it and include it, then that should work.
yeah, so I can like that's something that we will have to like try and then decide. I don't know
Yeah.
if yeah, yeah.
Yeah, and some of the VGG data sets or the uh, other, sorry, not data set, VGG, CNN or other CNNs which I used are completely different. Of course, we create our the same data formats or uh, the data streams which are created, data generated into an array, and then work with that array. That's the same procedure I also used.
Yeah.
And I shared the code as initial training also. This you might already have seen it. There again, we'll be training in terms of folders.
Yeah,
So folders will be taken into consideration as M and all, and then we run across it. So
yeah.
my question will be, if we train our own VGT data sets, that would be a little waste of time. So if there is a common VGD CNN neural network or the deep neural network, that would be a good idea.
Yes, VGG16 is common. It's like
Yeah, VGG16 is common. After VGG16, if you want to change the number of
okay,
layers
okay. So after
or
VGG16, we will be using traditional machine learning algorithm. That's why we have a tabular data set. This we will be using this tabular data frame for our model. We will not be using deep learning models. Uh, Team 2 will be working on deep learning model. Team 1's task is
okay,
only to perform traditional machine learning algorithms for classification.
okay, got it. Okay, thank you.
Okay, no.
Yeah, yeah,
Uh,
yeah. That's it from us.
okay, okay. Navya,
Yeah, I have one question regarding the presentation. I read in the paper that you shared on the channel regarding the CNN model as well as the transfer learning. In that paper, there were three kind of approaches, like three ways to apply transfer learning. One way was like all weights in the convolution layers were freezed and we only changed the fully connected layers. Uh, as it was written in the paper, it was suitable for the small data sets. For the medium data sets, what it was doing was it was again performing training on some last weights of the convolution layers. Like only about half of the weights were freezed and the other one and the remaining ones we again performed training.
yeah,
So
yeah, that is called. I think it's called fine tuning, in which we we freeze a few convolution layers and we only use uh, half of the convolutional layers.
okay, so will we be doing in this model also, or is it
Y-
is not suitable for this?
no, no, we will be doing that, but like right now we are only it's only like the first wave of experimentation. So right now we will experiment with different types of cropping and augmentation, and after this we will try to uh, do what you mentioned, the fine tuning thing, and after that we will try using a different base model. Like right now we are using UG16. We will then later on we will use ResNet or any other base model. So there's a lot of stuff that we will be trying. And yeah, fine tuning is also on. I'm also considering it. So yeah, we will be trying that as well.
Thank you. That was all from my side.
Wallace.
Oh, just asking, do you want me to present the notebook I created in the weekend? So
Yeah, if you want to
just let me know.
yeah, just share your screen and go ahead. Let me just ask Dheeraj what he has to say, and then you can start your presentation. Dheeraj,
Okay, sure.
Yeah, hi, Owais, and thank you for wonderful presentation. So I am pretty new to this computer vision, but one question, like the train and test data sets which you have created, the NumPy array, it can we like you are expecting us to use the classification models, right? Like XGBoost or decision trees or maybe any other
yeah,
classification
exactly,
model,
exactly.
right?
Yeah.
Okay, fine. So you can maybe share those via the Slack channel,
Yeah, I will.
and then I can.
Yes, I will share the training and testing data on Slack channel, and you guys can use it for classification.
Okay, okay, fine. Thank you.
Right. Neville.
Yeah, I think for Wallace's presentation, maybe it would be better to refresh the link.
Yeah. I will have to restart the meeting.
All right.
Yeah. So that's all.
So
Yeah.
so we should leave and then I enter again.
Yeah. I'm going to end the meeting and I will restart it right away.
Okay, so see you soon.
Okay. Wallace, just wait a few seconds for others to join, and then you can share yours.
Okay, no problem.
Wallace, you can go ahead with your presentation.
Okay, let me share. Can you allow me to share, please? Okay, let's see if I can. No, nice. Uh, so can you see my screen?
Yes.
Let me move this here. I'm sharing the notebook. Can you see?
Yeah.
Yes, go ahead.
Okay, so basically, I start studying this topic, so it's the first time I'm using that. And then I started by this tutorial. That's this one here. So I shared this in the channel. So what I'm doing, I'm following this 1 second, this method one here from this article, right? So I adapted some things, and also I used uh, some things from the video that Owais provided in the channel, and also basically some other details I found in the chapter 8 for this book, right? So if you want to know the reference. So basically, I'm using the files that are in Google Drive. I shared with you this folder. Then we have the images provided by Owais So this is non-cropped, and this is cropped by Owais. And this one is the set of images with Kiran's method for cropping. So you can copy this if you want to try. And then what I'm doing here is copying that from the Google Drive. I'm loading the files here. So, and then I'm creating the, 1 second, that's just, I'm creating the folders. And basically, we need to have one folder with all data. So separating in the classes. So class 0 is all cells, and class 1 is ham cells, right? And then we have another folder to separate training, validation, and test sets for different classes. So with this function, once we provide the input folder with two folders inside it, so ham and all, with this command and this ratio, or training, validation, and testing, this command will create the folders separated that you can use, right? So, and after that, based on this procedure, we can create train dataset, validation dataset, and test dataset automatically. So always use a different method, but the idea is to be the same. So in this case, the labels are created automatically by using TensorFlow and Keras, this TensorFlow and Keras function. So that's the difference from what we always presented in his notebook, right? So can you hear me? Can you understand?
Yes, yes. So I did the labels thing manually, and you did the image dataset from directory. You use the Keras library. Yeah, yeah, I can understand
Yes.
what you. Yeah,
Yeah, this function is do this automatically, right?
yeah, yeah. It assign labels to the images based on the folders that are inside. That the images are stored in. Yeah, yeah. Go ahead.
Yeah. So, and this is did randomly. So we set the seed, so just to make it replicable, right? And then I just plotting some images to see if the process is right. So I did this different ways. So in this case, I'm using the image cropped by Owais. So I did also for Kiran's crop method. And then I create the pretend model. So it's ResNet, convolution ResNet. So in this tutorial, it is using this pretend model, and also on top of it, a classification model as well. So I'm in the two teams. So I'm supposed to study traditional machine learning methods and also deep learning methods. So I'm trying to do both things here, right? So if you want just to get the features, we just use only this pretend model, or if you want to use a classification set of layers on top of it, we can do classification after the feature extraction, right? So in this case, I use these classifications suggested by the tutorial, and then I applied this classification to the test set, and these are the results based on this neural network classification proposed by the article. And the results is not that good as of now, since we are seeing the papers levels of F1 score up to higher than 19%, right? So for this first try, we did not have a good result. And then after that, I start trying other methods. So similar on what Always did, I used this pre-trained model. I also tested VGG16. And now I'm creating the features vectors for training and validation, and also for the labels by squeezing the final matrix of features in a single vector, right? So we are supposed to have this 11,000 vectors with this size. So we have higher than 50,000 features in each vector of E, or 50,000 variables in each vector to use as classification, right? So then I also get the labels and start a process with classification. I'm using standard scalar here. I'm not sure if is the best way. Always using dividing the features by the size of the pixels. So after the feature feature extraction, I'm using this standard scalar just to create the classification models. And I tried different methods. So I started with logistic regression standard, created the classification model with scikit-learn, and then I've got similar results from that with the deep learning suggested by the paper, right? So here is the table for the training set. So it's clearing overfitting data, right? And the result for the testing set is not that good as well. We using the set of images. I tried that with Kiran's crop as well, and the result is quite similar, right? After that, so here is just the ROC curve. So this is for training set, so it's clearing overfitting. And for the test set is lower than 50%, so it's worse than guessing the classification process, right? So in the sequence, I did random forest. I was not able to run XGBoost, so even with a Colab Pro account, for this number of for this size of data, I could not have enough memory to run XGBoost. I don't know why, so I need to try more. But for traditional machine learning methods, I just tried logistic regression and random forest, right? So, and the results is similar here, overfitting in the training set, and then about 50% accuracy, and also F1 score for this set of data. Just remember, so it's already augmented and also cropped, right? So we have a balanced set of positive and negative classes, right? So the results are quite similar. So I think we need to try more different methods, and also hyperparameter tuning. So I was thinking to try Optuna, as Rich suggested in the last meeting on Saturday, to see if you have any improvement on this process, right? After that, what I did here, I used feature importance. Since the paper, I think it was shared by you always, that paper that applied feature selection on the
Uh,
data to reduce the dimensionality, right?
yeah. So the paper that I shared, they used random forest and ANOVA for feature selection.
I think they used three different methods, right? So I just tried random forest. So we have 50,000 features. The idea is to reduce the features for a small set of features that have most contribution in the classification process, right? So I'm just getting the feature importance based on the random forest, and then I'm selecting the features that sum up 80% of contribution in the importance for this problem. So from 50,000, for this case, we can reduce to 11,000 features in each vector, right? And then I try to see the results. I applied these select values to the original vectors after the feature extraction. And then we have reduced vectors here. And I applied the random forest again. But unfortunately, after feature selection, I didn't get a different result or significant improvement on the results for this classification with machine learning. So what I'm thinking is first, try to do some hyperparameter tuning to see if we can have a better classification. But I was wondering if our problem is not in the pre-trained model. So I tested it with VG, VGG16 as well, and the results were quite same for the models, right? Even for deep learning models and for machine learning models. So I'm not sure, as we are discussing in the channel, if the transfer learning is able to get the features for this set of this kind of images without a special training for this process. So it's just speculation, hypothesis from my side. I would like to see if you guys have more experience on that. What should be the best approach from now on? So I would like to try the same approach here with the data provided by Owais training and test set. But after this set of tests I did in the weekend, I think we can find similar results, if I'm not wrong. So basically, it's it that I want to show to you. I'm not sure if everything here is right, since I told you it's the first time I did that. I didn't have time to go in every single detail for this code, so I try to adapt different things from different sources. So that's it.
Yeah.
If you have any questions or suggestions, I'm open.
No, I saw your whole notebook, and the thing is that we can't really get disappointed about the result right now because this is just our first try. So uh, we shouldn't be expecting like great results from our first try. So I would say that this was pretty much expected that we will get not so good results. So we should not it should not disappoint us. Okay, it was expected.
Yeah,
And
yeah. So I think it's part of the process, right?
yeah, yeah, great work on the notebook. And yeah, just like you mentioned, I will share my test and training data set. So just try the same classification method on that data and see if that has any different result.
Okay, let's do that.
Uh,
Thank
yeah,
you.
thank you for sharing your notebook. Neville,
Welcome. So, okay.
Yeah, actually, yeah, I just wanted to additionally add to your point that also, I don't think we should also compare our results with a deep learning algorithm or a CNN model, because, those will have way better results than a traditional machine learning model. And yeah, we should be prepared to have these bad models, because we can always compare them and do a good comparison on how we've improved it.
Yeah, it's almost certain that if deep learning models will have way better results than our traditional models. But yeah, you are right. Yeah, it's just the beginning. So like I already mentioned that it's not something that we should be disappointed about. And there is a lot of stuff that we still have to do. So hopefully we will have somewhat better results by the end of the project. Uh, Kiran?
Hey, hello everyone. I just wanted to ask, do you need any information from me regarding the folders or how it is done? Or
About
do you want me to explain the code which is written there, the crop
yeah,
code, or
if you have
okay,
like done anything, just share your screen and
sure, yeah.
yeah.
Okay, OS disabled participant screen sharing.
Wallace make Kiran the host so he can share his screen.
Okay,
Wallace,
So let me try to, how can I,
there is a small icon on Kiran's name on the three dots.
oh, okay. So make host, right?
Yeah.
Yes.
Yeah, go ahead, Kiran.
yeah. Yeah, is my screen visible?
Not yet.
Yeah, not yet.
Okay,
Yeah,
is it visible now?
it's visible now. Yeah.
Yeah.
Yeah, yeah. As I said, basically I did it in the Google Colab. These are the input libraries, and this is how we connect to the Google Colab. I suppose everybody knows about it. And so here I'm taking two paths, mainly the all path and the M path. I'm just taking single folder at a time. That's the main idea here. And I'm just working on a single folder here. So the main crust of the code is here in crop underscore img. So basically the concept which I used is try to find try to convert it to a grayscale image or a binary image using Otsu as a threshold value. It automatically picks the uh, threshold here. So based on the threshold, what we get is a complete binary image. So what will my code do is it tries to find the white pixel or wherever the in terms of x-axis and in terms of y-axis. So it will take the minimum and maximum coordinates value, pixel coordinates value. So based on those coordinates, we are cropping the image here. That's the major concept which is coming into picture here. Okay, it's a simple concept, but it gives out a better results. So based on those maximum and minimum value with a plus or minus 3 pixels or something like that, we'll be able to crop the image here. So that's how the whole code works. So, and within the given folder, I'm trying to create a new folders called as new all crop path, new crop path. So when the folders are created, and each and every image is reducing a for loop. So I will read the given image from the given file path. After reading the image, I check if the image is null or not. If it's null, I will break the for loop and go out. And Here I'm trying to use the same function, the crop image function, which is written there, written on the top here. So based on the output given out by the function is a crop image, and this crop image will be returned to the folder new all path or new hem path. This is for all folders, and this is for the M folders. This is a simple code for cropping. But the only thing is the little intelligence which has been added here in terms of getting white pixels with a dark background. It doesn't work for other images. That's what I said. If you want to work on a Kaggle image, the algorithm will change again. It will be complete different thing. So this was the with respect to crop, and this is just the initial training which we created. Here I am, as you already know, guys, I've just taken a folder for training, and this is the validation folder. So what changes I made in terms of validation folder is, I created, I separated the data and created the data as hem and, oh, sorry, wrong folder. It's a little bit slow. Yeah, it's here. So in validation data, I separated the data into all and M so that it will be easy for me in terms of coding to differentiate, or for the code to differentiate between which are all images and which are M images. This is one of the major changes when compared to your codes which are done. Sorry. Yeah. That's one thing. So of course, we'll create a data structure here. Image data generator creates the data structure for the images, saying that it's a rotation. And if you want to fill the image based on the given 250 crisscross, whatever input size you get based on the nearest possible image pixels, there's an algorithm. I forgot its name. It uses that algorithm there. This is basically we are creating a data structure. How will be the image looking, or what are the kind of input image which goes into it? That's the main concept. And again here, we'll be talking about train data, validation data, and test data generator. In both for my train data as well as validation data, I'm creating two classes, M and all. For since test data, do you have a CSV file which contains information about test data files?
I think so. You want the official information that came with the dataset, or
Yeah, in order to show how accurate is my algorithm, I tried out with VGG16, and I tried out with exception also. Of course, exception gave me a better accuracy when compared to VGG16 with respect to validation data. VGG16 gave me around 0.67 accuracy, and the maximum it was 0.69, whereas exception data, exception model gave me a better accuracy when compared to VGG here. You can see the accuracy is far better than the VGG16. So what I saw in other code was, means how are you validating the data? Here, in order for me to validate data, I just separated my data to all and M. So that's how we validate based on the two classes.
yeah. So in
Yeah.
the official folder, in the official dataset, I think let me just check it again. But in that dataset, in the validation folder, there is a CSV file. There is a CSV file that has information about each image. Let me just make sure.
Yeah, it's there for validation. There is a CSV file.
Yeah, in the validation.
Yeah, in validation, but not for the testing, I suppose.
Yeah,
Yeah,
it's
for
not
the
there. No.
yeah for the
Testing, yeah.
testing there is no CSV file. So I guess if you have to like cross-examine your result, and you need a CSV file for that, then you will have to use the validation data folder as your validation data for the model.
Yeah, means my question is, in order to save my VGG16 or exception is working well, I need to compare my output results with the test data. Of course, it's giving me some accuracy with respect to validation data of 0.69 and 0.83, but I'm not sure. What if some new data comes into picture? Is that right or not? How do you say it's working perfectly? At least, how do you say that 0.83 is good?
If
Yeah.
if your trained model is achieving 89% accuracy,
With respect to validation data, that's it.
yeah.
Yeah.
So then that means that it will do the same for unseen data, because the validation data is also unseen data. It's not used in the train during the training.
Okay.
So yeah, so if it's giving you 89% score on the validation data, that means that it will perform the same on unseen data.
Yeah,
Hey, thank you.
just
My question was, is that 1 BMP, 2 BMP? Are this validation data or test data? I want to just confirm with somebody else.
Yeah,
I'm not
okay.
yeah,
sure.
this
So
is
okay, so
the validation.
It's
okay,
validation. Okay.
okay. Yeah, so I don't know if this I haven't checked this CSV file in full detail. So I'm not sure if these one, two, or three, where are these files in the folder? But
Yeah, this one is
Okay.
just to add on. It's there in the validation folders. They've given us these are the new file names for the images. 1, 2, 3.
Yeah.
It's there in the validation folder. So even if you get like 89% accuracy on the validation, it's pretty much giving you that accuracy for unseen data as well. So you're good to go.
Okay. Thank you, guys.
thank you,
Thanks for the input.
sharing your notebook, Karen. And yeah, Karen, I have like I've already mentioned, I have 3 sets of training and testing data frames that I have saved in pickle file. So in those 3 sets, the third set is basically using your method. I have used your method for cropping the images. So I have already used your method for cropping the images, and I will be sharing that data frame with you guys after the meeting. Yes, go ahead, Navid.
Actually, I just want to clarify with all three of you, like Wallace, Owais, and Kiran. By scaling, do you guys mean normalization? You're dividing it by 255, right? So that's normalization, right?
So the scaling that Wallace was talking about, uh, he used sklearn's standard scaler. So he was talking about scaling the features in tabular dataset. Okay, so
Okay.
yeah, and the scaling that I was talking about divided by 255, that I was basically talking about scaling the pixel of the image.
Yeah, yeah,
Yeah,
yeah.
so it
Okay.
was different type of scaling. Uh, the one Wallace used, he used it for scaling his tabular dataset, and I used it for scaling my image pixel.
Yeah, yeah. So you normalize the pixels,
Yeah,
right?
yeah, yeah.
Okay.
Yeah. Same
Okay.
here, Naval.
Okay.
So
Okay. All right.
Yeah, we are trying to get a standard input image for training,
Yeah.
256 or
Understood.
450 or something like that. Yeah.
One cash question about that. So, always you scaled the image before picture extraction, right?
yeah, it's pretty much compulsory to do. You have to scale your images before feeding them to a neural network, uh, because then the neural network does not perform well on it. And it's something that I have tried multiple times. So if you don't,
Okay, so I think I didn't do that. So I will check if the code that I get from the tutorial is using that. If not, I will change to see if I have any
Yeah, so
problem.
if you are not scaling your images before feeding them into a deep learning model, then it's almost certain that the model will not perform good on it because
Mm,
almost all the model expect the images to be scaled.
okay, I will check that.
Always.
Yes.
Actually, I had actually used your code. Just the difference is I used Kiran's crop code, and then I added adaptive histogram equalization um, with normalization afterwards. Um, so, so the feature extraction, isn't there a way? Yeah, there's also a way to do it through NumPy as well, right?
Feature extraction.
Yeah.
I am not aware of any way of like it's not something that I'm aware of, but yeah, I'm not sure. Like
Okay.
I haven't looked it up. So
Okay. So
but
Kiran says we can use NumPy.
yeah,
Okay. All
Karen
right.
say so there may be other, but I have never checked it. So
So also you had used the VGG model for the feature extraction, right?
yeah,
Okay. Okay.
and
Because
I
that was yeah.
and I have like a long list of things that we will be trying throughout the project, and the adaptive histogram transformation of images is one of them. So right now, I want to like get results for these three sets of data frames that I will be sharing with you guys. And once we have them, then I will move on to the next method. So the next method would be maybe it would be like try using a different base model for feature extraction. So right now we are using VG16, then we will use ResNet or any other, and then we will get results for using that method, and we will store and we will record those results with ourselves. And after that, we will try a different method on it, and we will keep getting results. And by the end of the project, we will have like we will have checked a bunch of different methods, and we will have a long list of results. So yeah, so that adaptive histogram is also on the list. So we will be checking that out.
Okay. Okay. Yeah. Because I have done all that. I just need to do the feature extraction and then the model training with the traditional ML algorithms. I was thinking maybe SVMs or something else, maybe a XGBoost. So maybe I'll let you know by tomorrow.
Yeah, yeah, okay, sure. Yeah, sure. Um, there's only 3 minutes left in the call, so uh, if anybody has anything to share, uh, yeah, so I will share the three sets of training and testing data in the channel, and I think that everyone should train a few classification models on it and check what kind of results uh, do we get from using classification.
Okay, so one last question. Since you've already done the VGG, can we also just, try to do with the different models for feature extraction? Like, we keep the code consistent, like the previous code consistent, like the augmentation and the um, processing and scaling and feature extraction. But I mean, within the feature extraction method, can we try a different model
Yeah,
instead of
yeah.
VGG16?
So
Because
that's exactly what we will be doing. And if you want to like do it from now on, like if you want to try it right now, then go ahead and try it. Yes,
yeah,
that's exactly how I was planning to do it. So we will keep
yeah.
the rest of the code the same, and we will only change the feature extraction part.
Yeah, because it would be redundant for us to use the same VGG16 for feature extraction, I feel.
Yeah, yeah. Um, yeah, thanks, Kiran, for sharing your work and your efforts in cropping the images. Uh, yeah, so if nobody has to share anything else, I will end the call, uh, and and I will share the file with you guys, and we will talk about it in the channel. Yeah.
All right.
Okay.
Okay.
I
Thank
think
you,
I
guys.
think
Have a good day.
have a good day, Wallace. I think the meeting host is Kiran. So Kiran, you can
Hey,
end.
no worries. You are the host. Thanks for setting up the meeting. It would be quite fruitful if you set up the meetings like this. Thank you, Owais, actually,
Okay, okay,
for
you're
setting up the
welcome. You're
meeting.
welcome.
All right. Yeah.
Okay,
See you guys on Wednesday.
okay. Thank you everyone for joining. Goodbye.
Okay, bye.
Hey, thank you all. Bye.